So going over to the set time module, takes in the inputs and then outputs hours, minutes, or seconds. So based on left, center, and right, it chooses the unit that you want to change. And so based on that unit, the outputs of up and down go to whichever function is the right function. So unit changes here, and that makes sure that up and down goes to the right function here. Now we're gonna go over, for example, set second or minimum or minute, and it takes in up and down. And so if it's going up and it hits 59, it goes back down to 0. Otherwise, it adds 1. If it's going down and it's already at 0, it goes to 59. Otherwise, it subtracts 1. And hours work the same way. Okay, so throughout this entire time, we're either pressing button up or button down. Now, depending on these impulses shown here of left, center, right, you're changing hours, minutes, or seconds. So we're going to zoom in, and not too much. So it goes 14, 15, 16, 17. So it is correct. And then after you switch, it holds that value and starts changing minutes. So 1, 2, 3, 4, 5, that's the correct direction. And we're going to make sure that when it hits 59, it goes to the right value. So sure enough, 59 goes back to 0. Now we're going to zoom out and verify that it is doing this correctly when you go down instead. So you're going down now because you're pressing the button down button. Then you stop. It holds that value. Now it's starting to switch minute, and the value of minute is changing down. Now we're going to verify that. Sure enough, here it hits 0 and it restarts from 59. Module, it's actually just the clock, the thing that actually counts, and it takes in a clock, a reset, a load, and it outputs the current time. It also takes in the set values for when you actually set the time. So we're driving the clock. We slow down the 100 megahertz to just 1 megahertz so that it changes every second. And we use a counter for that. You can work out the conversion yourself. So then it goes through here. So this is saying like the least priority is counting because it's only when load and reset are inactive. And so it goes 59.0, 59.0, and of course 24.1 for the hour. So this does the actual counting. Now, if you're not loading when you press reset, then these values will go back to hour 1, so 100. Now, if load goes to 1, that takes priority over resetting and counting. And so at load 1, you're going to load the set values. So the set values come from the set time function. So if you set the time but don't load, then nothing will happen. Over the test bench for TikTok, which is the clock module, right here I adjusted the frequency so we can actually see the changes more rapidly. And so seconds is changing very fast, and 1 minute is changing according to this. At this time we have to reset, and so it starts back from 0. We're going to zoom in. So you can see that it's increasing, and then at reset time it goes back down to 0. Now we're going to see what happens to make sure that it actually does change accordingly when it hits 59 seconds. And there it is, 59 seconds restart, and minute goes up by 1. So we're going to zoom out, and we're going to go to the time where we actually load the values. As you can see, these values aren't loaded in until load goes to 1. So this entire time, as soon as you hit load, the values update, and they're going to stay like that until load goes off and we hit the next clock cycle. So now, at this time, it's 24:59:59. So at this time, when 1 more second has passed, you restart, because it goes, right? You go from 24:59:59, now you reset to 1 a.m. So it goes back to 100 and it starts counting all over again.
So this is the alarm module, and we're gonna have these inputs that are gonna come from the clock of the top module. We're gonna have also these inputs which are gonna control the alarm, and then we're gonna have the alarm output and the display for the time. So we start with the setup time for the alarm, and everything starts at 0. Then we're gonna have 3 options, either C hour, C minute, or C second here. And let's say, for example, C minute. If C minute equal 1, then we can have 2 options, either plus or minus. If it's plus, minutes will increase by 1. If it's minus, it'll decrease, and if plus is 0, minutes will not change. The same thing will happen for seconds, and same thing will happen for hours. Then it'll go through a binary to BCD converter to split up the numbers. For example, if seconds equals 59, TS2 will be 5 and TS1 will split up to 9. That'll serve to connect to the alarm function. Now we have the values here, and reset will push all the values to 0. And once you turn on the alarm AL on equals to 1, then the code will evaluate if alarm equals to the input time, and if that's true, then alarm will be equal to 1. And then we also have LD alarm. LD alarm, when it's 1, then the alarm time will be equal to the setup time, and then that will be equal to the output. And if LD alarm equals to 0, then the output will be equal to the setup. So here we have the alarm clock test bench, and we also have the waveforms here activated. Just so we can go real quick with one example. Cmin here is activated at 1. Then we have a +1 here that will change the minute 1 from 0 to 1. And then we activate the alarm on here at it equals to 1. And then we also activate LD alarm. And as we can see, alarm will be equal to 1 because the time matches with the input. And then once it reaches the stop, alarm will go back to 0 and it'll continue.